Welcome to all of you. Now we discuss about the question about 2023 SageMath Semester 4 Mathematics Honors Paper ACC Skill Enhancement Course B2.1. The question paper is this. First question 1A. What will be the output of the following Sage code? 17 by 2 minus 8 quotient modulo division modulo 3 plus 19 double slash 4 minus 2 to the power 2. The question 1A. First we check this part separately. So first we write A equal to 17 by 2, B equal to 8 modulo 3, C equal to 19 double slash 4. That is actually, this is called float division, and this is the print ABCD, and last print is total this result. First we stop this, and next we run this code. So here we see that A equal to 17 by 2, so A equal to 17 by 2, B equal to 8 modulo 3, so this is the remainder, so 3 to 6 and remainder is 2, so B equal to 2, and C and 19 double slash 4, this is the float division, so this is actually the quotient, so 4 16, and so this is the quotient is 4, this is the C, and D is 2 to the power 2 caret 2 is also 4, so A minus B plus C minus D equal to 13 by 2. We put all hashtag before this line and off this line, and so run this. Answer is 13 by 2, so correct option is 2. Correct option is 2. 13 by 2. Question 1B. What is the correct code in Sage to find the value of pi correct to 10 decimal places? And this is the code. In means numerical approximation, numerical underscore approx, bracket pi comma d is equal to 11. If we put 10 here, then we get actually we here the 10 decimal places. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 decimal places. If you put 10, then you get 9 decimal places here. So correct option is 3. What will be your code in Sage to evaluate sine inverse half? Sine inverse half, we write here A sine half. Actually, this code is this A sine half, sine inverse half, and this we know that sine pi by 6, sine 30 equal to half. So this equals to pi by 6. Here we answer is this 1 by 6 star pi means this pi by 6 is the pi by 6. Next question, I by 6. A sine, actually this is the A sine half. A sine half will be called, this is the A sine half. What will be the correct such command for computing a to the power 10, where A is the 3 by 3 matrix? This, so correct option is the matrix, first bracket, parenthesis, next third brackets, this within third brackets, you write this first third bracket 171, this is the row wise, actually write here row wise, comma, third bracket 1 comma 1 comma 0 comma third bracket 1 comma 3 comma 2 3 comma 1 and double star 10, or you can write this matrix capital N here, and this the caret sign to the power, that is the to the power 10, or small matrix small n is the caret sign 10, caret sign 10 is the compute this, fill this. So correct answer is either this 10 1, correct option is 1. It is wrong, it is also wrong, so correct option is 1. Question E, which one of the following set commands is correct for computing the integral minus infinity to infinity 1 by 1 plus x squared dx? Here Sage code integral, first bracket 1 by 1 plus x square comma x, integration with respect to x here, minus infinity comma infinity, this is the range of x, limit of x, this, or you can write this such command, this integrate 1 by 1 plus x square comma x comma minus double small o comma double small o, this also means the infinity. Correct answer is 4. Question F, which one of the following such commands is correct for plotting fx equal to cos x in the interval minus pi to pi, close bracket. This is the question 1F, which one of these the following such command to correct the plotting of fx equals to cos x, this plot, first bracket, within first bracket, first brackets cos x comma minus pi to pi, and this is the run, and this problem run this problem, so you get this picture is this plot cos x comma minus pi to pi, you can get this picture. So correct option is 2. Question G, what will be the output of the following Sage code? A equal to 2, B equal to 2, C equal to 3, print A to the power B double star C. This is the correct answer is 256. Actually, this is the A to the power this B double star 6 to the power this. So 2 to the power 2 to the power 3. So 2 to the power 3 means B double star C means B to the power C. That is 2 to the power 3 is 8. So 2 to the power 8, that is equal to 256. Correct answer is 4. Question H, what will be the output of the following Sage code. A equal to this 1, 2, 3 within second brackets. B equal to this A dot symmetric underscore difference B. And this is the A delta B. That means the difference in the A delta B. So first the common elements of A and B, these sets, from these sets common elements is 1. So common element is 1. So uh, that is A union B minus A mate B. So this is the common element, this 1, 2, 3, common element 1. So uh, except common element A union B, that is 2, 3, 4, 5. Correct option is 1. Question I. Which one of the following Sage codes will provide the output 75? Actually, A is equal to 0 for I in these third brackets 10, 11, dot dot dot. Here is the question is wrong because this only here only there are 2 dots only. So all options, in the all options there are 3 dots. So this is the programming. This is the is equal to 0. Is equal to 0. So I starts from 10, 11, 12, 13, 14. So s plus I. This s is the old s equal to 0, and this s is new s. So sum all these. So run. If you put these three dots, extra dots in this, so there are type error. So if you put delete this extra dot, only 2 dot, 10, 11, 2 dots, dot, 15, and run this problem. So this is 75. If you the print is within the indent of for loop and then run this problem, then you will get this is at each lines this print is this 10, 21 is 0 plus 10, so 0 plus 10 is 10, and 10 plus 11, that is 21. So this line 21, and finally this, because this print is each within the for loop. This is the colon, and this is the indent or indentation for this for loop. So uh, without indentation outside for loop, if you put this line print is outside the for loop and run this, you get 75. You only get 75. So correct option is 1. Correct option is 1. But actually this is the wrong question because of 3 dots. So actually this is the wrong question. Next question, question J. Which one of the following Sage codes will not produce 120 as output? 120 so will not produce. Will not produce. Here, actual option is 4. This fx equals to x to the power 4 and integrate fx comma x 2 comma 3. This is the 211 by 5. Output is this 211 by 5 because all other commands, this is the fx equal to x to the power 5, fx dot derivative x comma 5, LCM 12 comma 40, equal to 120. You can check all these all are 120. So produce 120 and check this. So actually answer is 4. Answer is, integrate this, so answer is 3. Answer is 3. Correct answer is 3. Integrate this is the answer is 3. Correct answer is 3. Will not produce. Next, section 1. Question 2a. Consider the Sage code to find the factorial 73. Hence, write the Sage code to find the number of zeros in factorial 73. X equal to factorial 73. This is the inbuilt function factorial 73 within Sage code. Actually, this Python. The Python, this factorial is the inbuilt function 73. And so x. And this is the output is this. So factorial 73, a large number. P dot x dot digits. P dot x dot digits. And C equal to P dot count 0. So P is a variable and that stores the digits, separately digits 4, 4, and this x dot digits, and C equal to P dot count 0. So there are count 0 is 35 zeros here, and so C. If you put here, so P, SHOW, so P, and run this Sage code, and this is the this P display this the all digits separately. So here there are 35 zeros. Count P dot count zeros. This so we can write this P dot count 1, P dot count 2, and there are how many numbers of the 1 or 0 in this factorial this. Next question 2b. Write Sage command to find the numerical approximate value of the following expression correct up to 17 digits. Square root of 30 plus 2 to the power minus 0.04 whole divided by modulus value of sine pi by 4 minus tan pi by 4. And this is the numerical underscore approx. The square root of 30 plus 2 to the power minus 0.04 whole divided by absolute value of sine pi by 4 minus tan pi by 4, comma, digits equal to 17. So there are 17 digits, including 22. This decimal place and integer places. Next question to see, give the output of the following Sage expression exponential e to the power I into pi plus e to the power 0 plus log 10 to the power 3 to the base 10 minus binomial this 4, that is the 4 comma 2, there is the 4c2, this is the binomial, this is the inbuilt function binomial 4c2. So you can run separately this is a equal to exponential I into pi, and so you can write this. First put hashtag here, then remove hashtag, remove the comment lines, and separately we calculate this. So A equal to -1, B equal to 1, C equal to 3, D equal to, this is the minus binomial for 2, so -6. So add all these, A plus B plus C plus D equal to -3. So I remove the original answer, hashtag before the original answer, and again put hashtag from this command line. Actually, we can delete this. I run, so answer is -3. So correct output is this -3. Next question. I write Sage commands to find the number of days in 12,345 hours. Question C to 3C. Sorry. Question 2D is the write the Sage command to calculate all the square roots of -9. Question 2D. Question 2D. 2D is this. I write Sage command this square root -9 comma all equal to true. So this is equal to 3i minus 3i. The square root of -3. So plus minus 3i. 3i and 3i. You can write this fx equal to x square plus 9 fx dot root x. Alternatively, you can write this. Question 3a. Question 3a. Write down the Sage commands to determine the value of 55 minus 13 to the power 1 by 5 whole to the power 7. Fifth root of 13. Correct to 7 decimal places. Correct to 7 decimal places. Note this point, 7 decimal places. So this is the x equal to 55 minus 13 to the power 1 by 5 whole to the power 7. First we find p. P equal to the floor x. This is the greatest integer function. Actually, if you compute this p, that is so p in the next line, you can get this. P equal to is the floor. Floor means the floor function means the greatest integer function is the function that takes as input a as real number x and gives as output the greatest integer less than or equal to x. Example, -2.4 box -2.4, this gives -3, 2.4 equal to 2. So here this is the positive number decimal point, and remove this decimal point. So integer part is this here. So actually value of x equal to this point something, some decimals. So this 7 decimal places means this integer part dot up to 7 decimal places. Actually this is the decimal places. So this m equal to p dot in digits brackets. Actually p counts the number of digits. So in x, this floor x, there are 13 digits. So this is the 13 integers in this integral part of this x. So h equal to numerical approximation x comma digits equal to m plus 7. So m here 13 because there are 13 digits in the integer part, and plus 7 is the 7 decimal places. So h. So this is the correct answer is this 1 point this into 10 to the power 12. Actually, the integer part, that is the integer part is this 13 digits in the integer part up to 8 is the 1.58. Actually, this portion is the integer part. This 1, 2, 6, 8, 3, 2, 4, 6, 1, 5, 8 point this 2, 5, 6, 2, 4, 2, 8 is the decimal part 1, 2, 3, 4, 5, 6, 7. This is the this point put here point, actually this is the If you write, note this, if you write the numerical approximation, that is n x comma precision equal to 28, this gives this 1.2268325 into 10 to the power 12, and this is not correct to 7 decimal places, because this is the uh, actually approximate, this decimal places is this, but in this number actually this integer part point after this decimal part is this 2.2562428 and so on, so on, so on. So this is the correct answer up to the 7 decimal places. Next, write sage command to compute this 3 plus 4 to the power 1 by 3 cube root of 4 whole to the power 6 whole divided by 0.01 square minus 32. So this numerical approximation, this correct code is this bracket 3 plus 4 to the power 1 by 3 bracket close to the power 6 whole divided by 0.01 to the power 2 minus 32. 2.01 to the power 2, 32. Output is 9.31 and so on dot E7. E7. So this x equal to this. So x actually this is not a numerical approximation, and for that we put here in or numerical underscore approx. Integer object not callable. Shut down running code again, open the file. Actually, and this is in Jupyter. This is the correct answer is this 9.31966088426187 E7. This is the E7. E7 means that 10 to the power 7. Question C. 3C. Write such commands to find the number of days in 12,344 hours. So actually command is this. Such command is D equal to 12345 double slash 24. Print the number of days, second bracket, dot format D. Here the operator double slash is called the floor division. So 36 double slash 5. So 5, 6, 30, 5, 7, 35. So 7 is the quotient. So floor 36 by 5. Actually, this is the double slash 5 means the floor 36 slash 5 divided by 5. That is the floor 7.2. This is the nearest greatest integer, that is 7. But minus 35 double slash 5 is the floor minus 36 by 5. That is the floor minus 7.2, actually this is the minus 8. So this is the hours. So hours, 24 hours means the 1 day. So we divide by 24 number of days to count the number of days. Number of days is the actually quotient. We find only quotient part, and the remainder part, and this portion, you can write this 1, 2, 3, 4, 5 modulo 24. So this g equal to this, you can write this. So g is there at 9 hours, 514 days and 9 hours. So this part is the remainder part. So after division by 24, we get the quotient part is 514 and remainder part is 9. Delete this line. Next question, 3D. Write the sage command to find the divisors of the numbers 3 to the power 33 minus 1. The d is the divisors. Divisors is the inbuilt function in Sage. N equal to the length d. Alien len is the inbuilt function. The divisors of these, the how many divisors, the count total number of divisors. This the length means that total number of data. So total number of divisors is 32. Is the length of d is this. Next question, 3e. Suppose 50,000 is invested under the compound interest at 5% per annum. Write the Sage code to compute the interest amount after 4 years. P is the principal value, R is the rate of interest, N is the number of years. The formula P into 1 plus R by 100 to the power 4 minus P. The total amount this minus P is the principal amount. So we get the interest part this. So interest part is this after 4 years. This is the interest part. Next question, section 3. Plotting the graphs. This is the question 4a. Write Sage code to plot the graphs of the curve fx equal to x minus x cube. X belongs to minus 2 to 2 closed interval. Its tangent at the point 1, 0 and a big dot of size 30 at that point in the same plot. This fx equals to x minus x to the power 3. f1 is the derivative of this. Actually, this is the derivative. X derivative 1, x cube is 3x square, and say x0 equal to 1 point, and yx equals to fx0 plus f1x0 into x minus x0. X minus x0. So x0 is 1 because we find the point 1, 0. Actually, y minus uh, y minus y1 by x minus x1 equal to fx minus this. The formula is this tangent for the tangent formula. So plot yx, plot y. P1 is the plot fx. This is the P1. P1 is the plot fx curve, and P2 is the plot fx2. P3 is the point. P2 is the curve tangent at this point. This is the 1, 0 point. So x minus x0 by y minus y0. X minus x0 by y minus y0. fx0 by fx1. Derivative of this point. And this the P3 is the point 1, 0 and size is 30. So this is the point. And so this P1 plus P2 plus P3, P1 plus P2 plus P3. Question 4b. Write a Sage code to plot the function fx in the interval close to interval -1 to 1, fx equals to 1 minus x in this closed interval -1, 0, and fx equal to 1 plus x cube in the open interval 0, 1 as the piecewise function. So we write fx equal to piecewise. Piecewise is the inbuilt function in Sage. This first bracket, third bracket, first bracket, third bracket. This third bracket means the closed interval third bracket -1, 0, comma, and this interval, in this interval function 1 minus x, this the part is this piecewise function part. This next first bracket, within this next first bracket is this second part is the 0, 1. This 0, 1 is the open interval, comma, in this open interval the function of fx is 1 plus x cube. This third bracket close, comma, variable equal to x, variable equal to x, plot fx. So this is the function -1 to 0. This is the 1 minus x. From -1 to 0, this function is 1 minus x. And from 0 to 1 in the open interval is 1 plus x cube. This is the 1 plus x cube. Next question 5a. Write Sage code to plot the parametric curve x equal to t sine 1 plus t square, y equal to t into cos 1 minus t square for t belongs to this -2 pi to 2 pi. This t is equal to variable t, single invariant comma t, and x equal to t into sine 1 plus t square, y equal to t into t star cos 1 minus t square. Parametric plot, parametric underscore plot. This is the inbuilt function in Sage. First bracket x comma y first bracket comma range of t, parameter t comma -2 star pi comma 2 star pi. Then we get this picture is this. Next question 5b. Write Sage code to plot the polar curve r equal to 1 plus 2 cos 2 theta, 0 less than equal to theta less than equal to 2 pi. So first to define theta, theta equal to variable single quote theta, th. R equal to 1 plus 2 star cos 2 theta, polar underscore plot, first bracket r comma, theta range of the theta, first bracket theta comma 0 comma 2 pi. Run this program and you get this picture, output this picture. Question 5c. Write Sage code to plot the function fx equals to 1 by x minus 2 into x minus 3 in the closed interval 0, 4 and its asymptote if any. Fx equals to 1 by first bracket x minus 2 star x minus 3, p equal to plot a range of x, this x comma 0 to 5. Here we plot here x equal to 0, x-axis is this, x equal to 0 to x equal to 5. So we write this first bracket x comma 0 to 5, comma y minimum -25, y maximum 25. Here y minimum -25 is y-axis and y maximum is +25. This, comma detect underscore poles equal to so in single quote so. So actually this is the to find the asymptote. This detect poles equal to so. So p. So p, and this is the beautiful picture. This dotted line, the asymptotes of this curve. So you have to adjust this the x range and y range, and this is the domain of x 0 to 5. If you put this -10 to 10, and you cannot get this beautiful picture, this asymptote picture. So you have to adjust this the range of x and range of y. This question 5d. Write Sage code to plot the graphs x to the power 2, e to the power x, and sine x with different line style in the closed interval -10 to 10 in the same plot with the same axis. P1, say P1 equal to plot x square, and x range is x comma -1 to 1. Line style, single quote solid. This is the solid line, the x square. This is the x-axis, this is the y-axis, this origin, the solid line is this. P2 is the plot e to the power x, this dashed line. So this is the dashed line, this is e to the power x, this dashed line. And P3 is the plot sine x, this is the dotted lines. So this is the dotted lines, this sine x within interval -1 to 1, and -10 to 10 in -10 to 10. So actually in this question paper 5D, question paper 5D, style -10 to 10. So actually edit this -10 to 10, actually -1 not equal to -1, -10 to 10, -10 to 10. Put this range of x -10 to 10 and run this code. If you put this -10 to 10, the picture is not clear, and to get clear picture, we put here -1 to 1. Actually question is this -10 to 10, so you must write in the question paper answer paper this -10 to 10, but for clear picture you put this -1 to 1. For this interval -10 to 10, we cannot get a clear picture. But in the answer must write interval -10, 10. So run this problem within the interval. This is the -1 to 1 for getting clear picture. Next question, section 3. Actually, this is the calculus section 3. Question 6a, write Sage code to find the first three derivatives of ft equal to sine t square, and to plot them together along with the graph of ft indicating different colors and different curves. Here t is the variable t, ft equal to sine t square, f1 t is the first derivative of ft, this diff is the inbuilt function, and this t and f2t is the second derivative. So we write differentiation ft comma t with respect to t comma 2. Actually, second derivative this. And third derivative is this differentiation ft comma t comma 3. P1 is the plot of f, and range of t is -2 to color is black. P2 plot of f1, color blue. P3 plot f2, color green. P4 plot f3, color red. So ft equal to this ft. So f dash t equal to f1t, f double dash t equal to f2t, f triple dash t equal to f3t. So p1 plus p2 plus p3 plus p4 in a single graph. So first we ft is the function this, f dash t is this, f double dash t is this, f triple dash t is this. So in the black color is the original curve ft, and this blue color f1, that is f dash, and the green color f double dash, and red color f triple dash is the red color. Next question, question 6b. Write sage command for computing the derivatives fx equals to sine 2x plus 1 at x equal to 2 from the definition of derivative. So definition of derivative means this is the limiting definition. This is the limit x tends to 2, fx minus fa by x minus a. So x is the variable x, fx equals to sine 2x plus 1, and limit this fx minus fa by x minus a, limit x tends to 2. We write this limit is the inbuilt function in Sage. This is the 2 cos phi. First we find the derivative and put then derivative at the point x equal to 2. Question 7a. Write Sage code to evaluate the integral this. 7a, question 7a. Integration e to the power minus x cube dx. Integration, and this the integrate within brackets e to the power minus x to the power 3 comma x. And this is the output is this. The comma function is there. You can find the numerical approximation. Question 7b. I write Sage code to evaluate this definite integral minus 1 to 1 integration x sin x dx. Is the fx equal to x sin x dx? Fx dot integral x comma minus 1 comma 1. The output is this, minus 2 cos 1 plus 2 sin 1. Question 7c. Integration 0 to infinity x cos u divided by u square plus x square du. Is the forget means the before you define this variable x and u and this condition. So this condition x greater than 0. So forget all these conditions before programming. So x comma u is the variable x single quote or u single quote. Assume x is greater than 0. Fx u equal to x star cos u divided by x square plus u square. Fx u dot integral u comma 0 to infinity. The range of u is the u 0 to infinity. So answer is this 1 by 2 into pi into e to the power minus x. Question 7d. Integration 0 to 1 dt by whole root over t 1 minus t. Actually, this is the improper integral. Also improper at the point 0 and at the point 1 is 1 minus t. So we can find this improper integral 7d. Forget all these conditions before conditions. Just forget this first bracket. T equal to variable t. F t equal to 1 by square root of t into star 1 minus t. F t dot integral t 0 to 1. This is equal to pi. Output is this pi. Next, section 4. Section 4 is the linear algebra part. Actually, this is the matrix. Question 8a. Write the Sage code to define a matrix M whose rows are 1, 3, minus 6, 2, 7, minus 1, 0, 2, 2, 8, 6, 1, minus 5, 9, 0, 1. So this is the M equal to matrix ZZ. ZZ is the domain of this matrix and this field of the matrix. This actually ZZ set of integers collected from set of integers. This is the order of the matrix 4 and third brackets. This 1, 3, minus 6, 2, 7, minus 1, 0, 2, 2, 8, 6, 1, minus 5, 9, 0, 1. Third bracket close, first bracket close. So matrix M equal to M. Output is this. Matrix M equal to this. Output is this. Next question, 8b. This is the determinant M. So date M, that is actually the inbuilt function date M, value of the determinant, and inverse M dot inverse. So inverse is the inbuilt function. So inverse of the matrix. So find this inverse of the matrix determinant A equal to minus 420, and inverse matrix of this value of this inverse matrix is only this command M dot inverse. Next question, 8c. The M is the matrix M is the sum of the symmetric and skew symmetric matrix. So A equal to half of M plus transpose M, and B is the half of into M minus transpose M. This transpose the inbuilt function. So A equal to M plus M dash by 2. M dash means the transpose equal to A. B equal to M minus M dash by 2 equal to B. So A plus B is equal to A plus B. Actually, this is the M. Actually, this is the M. So output of the 8.C is this. This A equal to M plus M dash by 2. M dash means the transpose of M. We get this. B is the M minus M dash by 2. And so if we add A plus B, this, and this is the actual matrix M. This is equal to the original matrix M. Next question, 8D. What will be the output of the Sage code M00, M23? Actually, this position of the matrix starting from 0. So this first point is 1, 1. We call it 1, 1. But in the matrix Sage code, this is the position is 0, 0. So this is the 0, 0, 1, 2, 3, 0 column, first column, second column, third column. So this is the position 0, 0, 0, 1, 0, 2, 0, 3. In the second row, is the position is 1, 0, this 0th row, first row, second row, third row. So we write this actually 0, 0 means that this point is 0, 0 is the 1, and 2, 3. 2, 3 is the position this. So this actually this is the 1. So this is the M0 is 1, M23 is 1. Question 9a. Write Sage code to solve the following system of linear equations. This x plus y plus 2z equal to 5, x plus 2y plus 5z equal to 22, x plus 9z equal to 15. So this is the x, y, z. I have all variables, 3 variables, single quote within single quotes, x, y, comma, z. Solve this, third bracket, first bracket start, third bracket start, x plus y plus 2z equal 5, comma, x plus 2y plus 5z equal to 22, and comma, x plus 9z equal to 15, comma, x, y, z. Solve for x, y, z. So you can find x equal to minus 93 by 10, y equal to 89 by 10, and z equal to 27 by 10. Question 9b1. Write Sage code to input the matrix A 987 654 321 and to find the sum of all elements of A. Is the matrix A is the matrix from the field ZZ, set of integers, the 3 by 3 matrix, so 3, the matrix elements within third brackets 987 654 321. So the matrix is the matrix this. Now C is the sum of A. The sum is the inbuilt function. The sum of A actually is the column is sum of A. So if you put this sum of A, so this sum of A. So C. So we get 18, 15, 12. In the column is sum 9 plus 6 plus 3 equal to 18, 8 plus 5 plus 2 equal to 15, 7 plus 4 plus 1 equal to 12. And this S equal to sum of C. Actually, this is the sum of all elements of the matrix A. Sum of all elements, that 18 plus 15 plus 12 equal to 45. This is the sum of all elements, this. So we can write this command, single command, is equal to sum bracket sum of A. First sum is the column sum, column-wise sum, and next sum is the sum of the column-wise sum. Next question, part B2. Also write the Sage code to find row-reduced equivalent form of A. This is the row-reduced equivalent form. This is the RREF, inbuilt function in Sage. This RREF, so B equal to A dot RREF. B is the row-reduced equivalent matrix. So this is the row-reduced equivalent matrix. This first element is 1, and below this first element in this column is 0. And this is the second non-zero element in the second row, this 1, and below this element, this 0, all this 0, and this is the row-reduced equivalent form. Question 9c. Write a Sage code to display the diagonal matrix of order 6, which all diagonal elements are 11, without entering from keyboard. So here, this is the wrong question, because this is the question in the question, question C, write Sage code to displace. So this word, actually this word is wrong. Displace, actually display of the diagonal. So this is the wrong question. A diagonal matrix of order 6, which all diagonal elements are 11, without entering from keyboard. D is the matrix QQ. Actually, Q is the set of all rational numbers, maybe fraction with integer, numerator and denominator, or ZZ. This 6 by 6 matrix, this 6 by 6 orders, and this all diagonal elements is 11. So 6 by 6 diagonal matrix, or all diagonal elements, principal diagonals are all 11. Is the diagonal matrix of this. Question section 5. Question 10a. Write Sage command to solve the following initial value problem: dy dx equal to 1 plus xy, y0 equal to 1. Here y equal to function, single quote y is the function, that is y equal to yx. P dissolve is the inbuilt function in Sage. Dissolve, first bracket, deep y comma x, actually dy dx. This is the dy dx minus 1 minus xy. So dy dx equal minus 1 minus xy equal to 0. This equals to 0, comma y, solve for y. So underscore method equal to true. P1 is the dissolve. This is the dy dx, differential dy dx y comma x comma minus 1 minus x star y equals to 0, equals 0, y, this third bracket, that is y, value of x, this 0, and value of y is 1. The initial condition is this. So from the first P, this you find the general solution of this. With this C is the arbitrary constant here. This is the first order equation, first order differential equation. So only one constant C, arbitrary constant. And this is the show method true. Show method true. This is the linear differential equation. And particular solution, this P1, put this y0 equal to 1. So you can value of C for this initial condition, particular solution, and we draw the graph for this particular solution P1, plot P1, that is the solution of the graph of the P1. The axis level is xy and dollar sign. This axis level is this x and y, and frame is true. Frame means this the axis, y axis and y axis. This the figure size is 5. This the figure size is the this axis figure is this 5. This y this figure size is 5, and this is the initial value problem. Next question. Question 10b, write the sage code to solve the differential equation dy dt minus t square sine t equal to 0 and to show the solution. Also, the sage code to plot the solution curves corresponding to the values of 1, 2, 3 for arbitrary constants. So this t is the variable t, x equals to function xt is the x is the dependent variable and t is the independent variable. So first independent variable t is the independent variable and x is the dependent variable depends on t, and solution is the variable. This is the dissolve differential dx dt minus t square sine t equals to 0. Solve for x and contribute underscore od equal to true. Actually contribute underscore od equal to true. Actually this is the contribute ODE is optionally true. Dissolve allows to solve the Clairaut's, Lagrange, Riccati, and some other equations. This may take a long time and is thus turned off by default. Initial conditions can be used only if the result is one symbolic equation, does not contain singular solution. So if you allow this solve this Clairaut's, Lagrange, Riccati, and some other solution, so contribute equal to this contribute ODE equal to true. This general solution is this solution, and C equal to solution dot variables this equal to 0, colors dark green, magenta, yellow, green, orange. P equal to graphics, and for P in S range, actually S range actually P in S range 1 to 4. This means P starts from 1, 2, 3. So P takes the values 1, 2, 3 only here S range. And S range can take any type of numbers, say either integer or decimal point. But if you put here range only can only take the integers. So S range 5 is the generates a list this 0, 1, 2, 3, 4. But range 5 is the Python integers this from 0 to 4, 0, 1, 2, 3, 4. So here is range P in is range this and solution 1, this solution 1 equal to solution dot substitute C equal to P. This C is the variable, so put C equal to P and G equal to G plus plot solution 1, and this range of X is -1 to 1 and color is the colors P. Actually colors is the colors equal to this COLS colors. We here give a list of colors. This colors 0 is dark green, colors 1 is magenta, this color 1 is magenta, color 2 equal to yellow green, and color 3 equal to orange. So when P equal to 1, that is color 1. The color 1 means this magenta. And P equal to 2, this color is yellow green. And P equal to 3, is the orange. Actually, P values takes from 1, 2, 3 only. And the C, this is the arbitrary constants, equals to P, that is when C equal to 1, when P equal to 1, C equal to 1. When P equal to 2, C equal to 2. P equal to 3, C equal to 3. So we get first this, when C equal to 1, we get magenta, this C equal to 1 variable, and C equal to 2 and C equal to 3. This is the general solution of this. If you put C equal to 1, we get this solution curve. For C equal to 2, we get this solution curve, and C equal to 3, we get this solution curve is this. So this is the answer of this. Next question. Question C, write the sage codes to solve the polynomial equation x cubed minus 9x squared plus 2x plus 48 equal to 0. X equals to variable x, solve inbuilt function, solve in sage command. x cube minus 9 star x square plus 2 star x plus 48 equals to 0, comma x. So output is x equal to 8 and x equal to 3. Let us solve the polynomial equation. Question 11a. Write the sage code to solve the boundary value problem. Y double dash minus 5y dash plus 6y equal to 0 with boundary condition y0 equal to 3 and y log 2 equal to 8. Here y equal to yx, function yx. P equal to dissolve this dy dx and d2y dx square. So differential y comma x comma 2, that is d2y dx square, minus 5y dash, that is 5 star differential dy dx, plus 6 star y equals to 0. Solve for y, and this is the boundary condition. This first value 0 is the y0, value of y0 equal to 3. Next value of this x1, y of x1, this log 2, and value of y is 8. So this solution, particular solution, this P, and print the graph of the above solution. Now this plot P, x within the x range -1 to 1, axis level, this x and y, frame true, figure equal to 5. The particular solution is this y equal to minus e to the power 3x plus 4 e to the power 2x, and graph of the above solution is this. Question 11b. Write the sage code to solve the initial value problem dy dx e to the power x minus 1 with y0 equal to 1. Y equal to function yx, use the dissolve bracket differential dy dx minus exponential x minus y equals to 0, comma y, solve for y, the initial condition 0, 1, so y0 equal to 1. So particular solution y is equal to q. This is the particular solution, the e to the power x plus y e to the power y, and this equals to this e minus 1. Actually solution is this, minus e to the power x plus e to the power y equal to e minus 1. Next 11c. Write the set code to find the roots of the polynomial equation x cube minus 13x square minus 121x plus 133 equal to 0. X is the variable x, fx equals to x cube plus minus 13x square minus 121x plus 133. So fx dot roots x. Plot x f, plot f, comma, brackets x minus 20, comma 20. Here the roots is minus 7, 1, 19 and 1. Here minus 7, 1 is the first component. This minus 7 is the root and 1 is the multiplicity. This is the there are three roots, minus 7, 19 and 1. If we plot this is the plot of fx. So it cuts the x-axis, this point, this is the minus 7, this point is 1 and this point is 19. All are simple roots, so multiplicity are all 1. Next question, question D. Write sage code to solve the differential equation dy dx equal to y plus root over of y square plus x square by x. This is the homogeneous differential equation. This is y by x plus root over of y by x square plus 1. This is the y is the function y x. Use the dissolved differential dy dx minus y plus square root of x square plus y square whole divided by x equals to 0. Solve for y. Show underscore method equal to true and contribute underscore ODE equal to true. Actually, show underscore method is the true. If true, then the sage returns the pair of solutions method. So here This method is the general homogeneous solution, and contribution true when this Clary Woods Lagrange and Riccati and other some equations to allows this solution this and this. So the general solution of this u equal to this, and solution x equal to this general homogeneous solution, linear, separable, exact, integrating factor including, and homogeneous, Bernoulli, generalized homogeneous, that's the Jane home. And this is the next question section, part 6. Question 12a. Without using inbuilt function, write a program in Sage to determine the total number of primes less than 100 and to print the list of such primes. A is the integer variable. Input, enter a positive integer. Print the prime number up to this format A, value of A, this number of format A. K equal to 0 for n equal to in range 2 to A plus 1. Actually, S in range means the integers, Python integers, starting from 2 up to A plus 1, so starting up to A. So in takes the values 2, 3, 4 and up to A. Flag equal to 0. D is the integer value of the square root of n plus 1. First find the square root of n and take the integer part plus 1. This is the D. For I in range 2 to D, the 2 to D means the actually 2 less than equal to I less than D. For I equal to 2, 3, 4 up to D minus 1. This. If n modulo I equals to 0, that is n is divisible by I. So flag 1. Flag 1 means this. Actually, this flag 1 means this non-prime. If flag equal to 0, k equal to k plus 1, print this total. This the number is print n. Actually, this is the n is prime number, and total number of prime is count this format k. K is the total number of prime numbers. So enter a positive integer 100, and this program run this program up to 100. Put this. So the list of prime numbers up to 100 is this. Total number of primes is 25. This n comma double quote comma int equal to this. If you remove this int comment, and this all these prime numbers listed in a column. These 2, 3, 5 and so on. Next question 12b. Write a program in Sage to find the arithmetic mean and geometric mean to the following data. Actually, this is the wrong question, because this question 12b, this geometric mean for minus 41, actually we avoid this minus, only we take these positive integers, this. So we correct this 41. N is the length of x, total number of data in total number of data is S is the sum initial value sum equals to 0. P is the product initial value 1 for I in range 0 to n, starting I equal to 0, I equal to 1 up to n minus 1. S equal to S plus xi. Xi means x0, this 14, x1 this 25, x2 is 63, and this up to x n minus 1 is this. Print sum equal to S, print product, and this for colon, there's indentation, this line under the for loop. So this is the S equal to this and P equal to this under this for loop. So you must put this indentation, and this print AM is the numerical approximation S by N and digits up to 4. And GM is the numerical approximation P to the power 1 by N, digits up to 4, 8, and print AM and GM. So total number of data in this, N equal to 8, sum equal to this, product is this, A equal to this, and GM equal to this. Next question 12C. Without using inbuilt functions, write a program in Sage to find the factorial of a number n equal to 10 with user-defined Sage function. Without this is the definition. First we define a function, this factorial n. We user-defined function, this factorial. You can change this name, this my factorial or others names. Fact n is the user-defined function. If n equals to 0 colon p equal to 1, else colon p equal to 1 for I in range 1 comma n plus 1 colon p equal to p star I, return p. This is the definition of factorial n. K is the integer variable. Input, enter the positive integer or 0. Print factorial of this, factorial of k, and the k is the input integer. Fact k, call this function fact k. This fact k is defined as here. N equal to 0, factorial n equal to 1, else this product equal to p into I, p into 1, p into 2, and so on. So output of this, put here n equal to 10. So output is this factorial of 10 equal to this 3628800. Next question 13a. Write a program in Sage without using inbuilt functions to find the median of the numbers 9, 11, 7, 32, and 14, 7, and 28. Here, capital A is the list, and third brackets 9, 11, and so on, 28. Print data list A. L is the length of A, that is the number of data. This L is the number of data. Print the number of data L. B equal to sorted. Sorted is the inbuilt function. So when sorted A means the B is another list in ascending order of the data of the entries of A. If L modulo 2 equals to 0, divisible by 2, when L is divisible by 2, and median 1 equal to B L for L double slash 2. Double slash 2 means the quotient division L. When L divided by 2, you get the quotient of this. Median 2 is the list B, from the list B, number of data, L by L float division, L double slash 2 minus 1. This median actually is the median 1 plus median 2 by 2. Else median equals to B L double slash 2. Print median is the median. Note that for descending order and C, another list not including in the problem, sorted A comma reverse equal to true. So then we write this descending order, inverse order. The descending order is this, not included in the problem. So remove the comment, remove these lines and put hashtag here. So actually run this problem. So this is the number of data is 7. So here 7 modulo division 2 is not equal to 0. So median equal to 7 module quotient division, the float division, quotient division 2 is 7 by 2. So 3 to 6, 2, 3, 6, 3. So this is the ascending order 0, 1, 2, 3. So this B0 is the 7, B1 is 7, B2 is 9, B3 is 11. So median is B2. BL double slash 2 is the 7 double slash 2 produce this quotient 3. So this is the median. Question 13b. Write a Sage program without using any inbuilt function to print the first 10 Fibonacci numbers starting with 0 and 1. A is the integer variable. Enter a positive integer. You must enter 10 because 10 first 10 integers, so a equal to 10. Print first 10 Fibonacci numbers are and dot 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 dot. First Fibonacci 1, Fib1 equal to 0 and Fib2 equal to 1. We call this variable Fib1 and Fib2. Print Fib1 this and Fib2 equal to this. For I in range 3, a plus 1. So a plus 1 means I starts from 3. This 1 and 2. First Fibonacci 1, I equal to 1, I equal to 2. So here I starts from 3. And up to a here 10, so up to 10 plus 1 actually 11, so I runs from 3 to 10 here, and Fibonacci 3 third term is the Fibonacci 1 plus Fibonacci 2 term 1 2. So print Fibonacci 3, this print, and now we redefine Fibonacci 1 equal to Fibonacci 2 and Fibonacci 2 equal to a new value of Fibonacci 2 equal to Fibonacci 3, and we in this for loop and start this. So this is the entire positive integer 10, and first 10 Fibonacci numbers are this. Question 13c. Without using inbuilt functions, write a program in Sage to find the LCM of two given numbers. A1 integer variable, input the first number. B1 is the integer variable, input the second number. A equal to absolute of A1, B equal to absolute of B1. So first this number means the integer. Actually, this number means A1 is the integer. Number means here integer. First integer and put here B is the second integer. And first, if you put A1 is negative, first A is the positive, the minus 5, so A is the 5. And if B1 is equal to minus 6, so B equal to 6. Product of this A star B, product of this A into B. If A equals to 0, B equals to 0, that is both integers are 0, GCD is undefined. If one of these 0, that is either B or A is equal to 0, then product is equal to 0, then GCD is the format of maximum of A and B. Maximum of B, the modulus value of A1 and modulus of B1. Else, R is the A modulo B. R is the A modulo B, while R not equal to 0, colon, A equal to B, B equal to R, and R equal to A modulo B, and print GCD of this and print LCM of this. Now, note that this is the greatest common divisor, GCD, the highest common factor of two or more integers which are not all 0, is the largest positive integer that divides each of the integers. This is the greatest common divisors. Largest positive integer, note that divides each of the integers. And the least common multiple LCM of two non-zero integers is the smallest positive integer that is divisible by both integers. And GCD of A and B is the GCD of mod A and mod B. LCM of A and B, LCM of mod A and mod B. AB are any integers not equal to 0. Now, when one of these A and B 0, GCD is the absolute value of the non-zero integers. So GCD of A, 0 or GCD of 0, is the modulus of A. But LCM of 0 and LCM of 0A are usually undefined. But in some other context, both of these be taken as 0. But in the special cases, this, so we avoid this LCM of 0 and LCM of 0A. Usually undefined, but in some other context, both of these taken at 0. And GCD of 0 is not defined. All integers are common divisors 0 and 0, so there is no greatest one. But from another point of view, 0 is its own greatest divisor if greatest is understood in the context of the divisibility relation. Actually, it is the lattice theory. So GCD 0 is commonly defined as 0, is from collecting from Wikipedia. In this case is not considered here. This is the typical case. So GCD 00 is not defined naturally. Usually GCD not 00, but in some context GCD 00 is equal to 0. Yeah. So we here define this GCD 00 is undefined here, and one of these 0 of these integers GCD is this. Now if we print this type this print this, if we remove this hashtag and run this program, this integer, first put this 18, next 12. So 18 and 12, the ABR 18, 12, 6. So actually ABR means this, else R equal to, this is the remainder after division of A by B, the R is the remainder. So when we divide 18 by 12, the remainder is 6. And then A equal to B. So here B is the A and this remainder equal to B. So then last step, remainder is 0. When remainder is 0, is division method. So GCD is the, this last remainder is this B, 6. So GCD is 6. And last we defined, and this LCM is the A1 a P by B. P means the product of this absolute value of this. P means the product of this absolute value of this A and B. So divided by P. B is the GCD of this. Actually, this is the LCM LCM of A and B equal to absolute value of A star B divided by GCD of A comma B. Actually, this is the P is the product of this absolute value of this divided by B GCD equal to GCD AB. Actually, this is the formula LCM of this. So remove this GCD of this. If you first again run this problem, 12, first input 12 small integer and next 12 put 18. So this 12, so this else this R equals to A modulo B. So here A equal to 12. So 12 is divided by 18. So when 12 is divided by 18, so 18 0 0. So remainder is 12. Remainder is 12. So this remainder 12 is A. This remainder is this next step. The next step is ABR. A equal to B. So A equal to B, this, and 12, 6, 18. Print, actually print print in this while loop is print this around this problem 12, 18, this. So in the first step, this ABR, in the first step, R equal to A modulo division B. So A modulo division B means A is 12. 12 is divided by 18. So 18, 0, 18. So remainder is 12. Remainder is 12. And next step, this A equal to B. Here A equal to B. So A equal to 18 and B equal to R. B equal to R. So in the previous step, R is 12. So B equal to 12. When we divide 18 by 12, this remainder is 6. Next, A equal to 12 and B equal to R. So A equal to 12 and B equal to R is 6. So when 12 is divided by 6, remainder is 0. We stop here. And this the GCD is the, and this B is the GCD of this. So, and this is the, remove this hashtag, put his, delete this line, a print line, and this print line, and run this program, and this 12 and 18. So GCD of 12 and 18 is 6, and LCM of 12 and 18 is 36. And this is the end of the Sage question 2023. Thanks to all again for watching this video.